So you see, if the product of reaction is gas, then what will happen is that when gas comes out, the gas will do some work. So system, if work is involved in the system, there is going to be change of internal energy. This is one way by which internal energy can change. Also, there are some reactions which is accompanied by evolution of heat, which are called exothermic reaction, and there are also some reactions which are accompanied by absorption of heat, which are called endothermic reaction. So during such cases also, there is going to be change in internal energy of the system. And a third way by which internal energy of a system can change is by mass transfer. If mass is introduced into the system, there is going to be change in internal energy. If our mass is taken out from the system, there is going to be change in internal energy. These are the different ways by which internal energy of the system may change. Now we are going to derive an expression for work done, that is work done in isothermal reversible expansion of an ideal gas. Okay, when we will see, we will get an expression, this one, W is equal to minus nRT into 2.303 log V2 by V1. This expression we will be getting. So for that, what we do is, again we are coming to this. We have a cylinder which is fitted by a frictionless piston. Piston means which is capable of moving up and down. Okay, and we have here n moles of ideal gas at temperature T and pressure P. And suppose the area of cross section of the cylinder is A, and say this length is L1, and corresponding volume say is V1. This length is V2, and the corresponding volume is V2. And since we have here sands kept, so it is at equilibrium. Now just if we remove a small speck of sand, so that there is small displacement produced, then work will be done. If a small speck of sand is removed, the piston will slightly go up, there will be displacement and work will be done. Why work will be done? Because we know work is given by force into displacement, and force is pressure into area. And suppose, as I already said, pressure is P here, so and area of cross section is A, so P into A into L. Suppose the displacement is L. Since we know area into length is volume, so we are getting P is equal to PV, and that small change, yeah, we can write dW is equal to P del V. P del V, small change. Now during that small change, pressure is kept constant. We can assume that pressure is not changing. Normally, as the piston will go up, as this speck of sand is getting removed, pressure is going to change. But this is a very small change, and we can consider the pressure to remain constant during that small change. So we are getting dW is equal to P del V, and or more importantly, this can be written in calculus form, P dV in calculus notation. Okay, so from here we can write since we know PV equal to nRT, so P will be nRT by V, nRT by V for P, so dV, And now total work that will be obtained as we bring the piston here in by small number of steps, by small number of infinitesimal changes. Total work will be, will be addition of all these works. So what will be integration of dw, integration, that means integration of nRT by v dv, integration, and your the limit of integration, it is from v1 to v2, the limit of integration. And now the constant, which are the constant, they will come out of integration. So what are the constants here? It is n is constant, r is constant, r is universal gas constant. Here we are carrying out the process in isothermal condition. The temperature is constant. So nRT has come out. So then integration v1 to v2, 1 by v dv. So that is nRT. Now 1 by v dv, is a standard form of integration. Integration, you must be knowing, or you should know, 1 by x dx is ln x. So similarly 1 by v dv integration will be ln v. Ln is natural logarithm. So here the limits are v2 by v1. So now this value we obtain this way. It will be ln v2, first putting this value, then minus ln v1. So the W is coming nRT. This quantity will be according to the property of log. Log, when log is minus, it becomes division, ln v2 by v1. And to change natural log to common log, we have to multiply by this factor 2.303. We multiply by this factor, so it is 2.303 nRT log v2 by v1. So this is what it came. Now you must be thinking of, here it is minus, why minus doesn't come? This minus comes only from convention. There is a sign convention for work. Work done by the system is considered to be negative. That means if the piston is going out, where work done is by the system, work done by the system is considered to be negative. That's why, here we should put a minus sign. Piston is going out, this is work done by the system. Work done by the system is negative. If work is done on the system, then work done is positive. But you will see whether it is because of these values, whether it is work done on the system or by the system, work done in isothermal reversible expansion of an ideal gas will be minus 2.303 nRT log v2 by v1. If you want to express in terms of pressure, it will be log P1 by P2. So remember one thing, this relation actually, will be, dW will be minus P del V always. So children, this much for now, for today. You will be getting this video today, and we will be doing some more more videos tomorrow. This much for now. Have a good day. Bye bye.